Alright guys, so I'm going to go ahead and start this video. We're going to discuss how to solve for variables. But before I do that, I'm going to go ahead and show you something very simple, very basic, in hopes of you understanding this lesson better. In front of you, you have a balance beam. And as you can see, they are both equal. Everything on the left is equal to everything on the right. Okay, so even though it looks a little different, they're equivalent. 4 plus 1 is 5, and on this side you have 5, so they're equal. Now let's say that I want to go ahead and change something. Okay, let's say that on the left side here I want to take away 1. I'm going to take away one number. Okay, if I take away 1, this is how it'll look. All of a sudden it will be uneven. It is no longer equivalent. So in order for me to make it equal again, what I do to one side, I must do to the other. Now remember, I took away 1 from this side. So in order to make it equivalent, I must also take away 1 from this side. The moment I take away 1, 5 minus 1 is 4. All of a sudden, it is equal again. So that's really what I want you to understand, guys. What you do to one side, in order to keep it equal, you must do to the other. That's it. Okay? So now we're going to discuss solving for variables. So let's go ahead and erase these numbers and let's write a couple of problems. Let's start with 3 plus g is equal to 7. Alright, obviously this is a very easy problem, and some of you are like, oh my god, Miss Benjamin, I know that's 4. You're right. So let's go ahead and write that down over here. G equals 4. Alright, but I'm going to show you using algebra. And we're going to think a little bit different because obviously our problems are not going to be this tiny. This problem here, I could give it to a second grader, a first grader, they'll be able to solve it. Okay, but I'm going to show you how to do it algebraically. What I'm doing right now is I'm separating my balance beam. Okay, I'm separating my rooms. I've always had to share my rooms with my brothers and sisters, and I've always wanted to have a room all by myself. So this is how I'm going to teach it. You will always be the variable. In this case, you're G. Okay? And think about it. Look at who's in your room. You have plus 3 in your room. You want to get rid of plus 3. But how do you get rid of plus 3? By doing the opposite operation. You always got to do the opposite operation. The opposite of plus is minus. So I'm going to go ahead and take away 3 from this side. Now remember, guys, like the balance beam, the moment you do something to one side, it's going to become uneven. It's no longer equal. So to keep it equal, what you do to one side, you must do to the other. So I'm going to take away 3 from this side. As you see, on the left side, you only have G. You're by yourself now. No one else is in your room. Now on the other side, 7 minus 3 is 4. So you just solved it. G is equal to 4. Let's try a few more. In this problem, we have x minus 14 equals 48. Alright, so what I'm going to do is right where the equal sign is, I'm going to separate my rooms. Remember, you are the variable, so you are x. Now, look in your room. Who is in your room? Minus 14. And you're like, come on, minus 14, get out of my room, minus 14. How do I get rid of minus 14? By doing the opposite operation. Okay, so the opposite of minus 14 is plus 14. Now let's think about integers. If you owe $14 and you have $14, you're going to pay your debt. You'll have 0 left. So that is gone. So finally you're by yourself in your room. Ah, feels good. But remember, guys, the balance beam, in order to keep it equivalent, what you do to one side, you must do to the other. So on this side, I must also do the same. I must add 14. So 8 plus 4 is 12. Carry the 1. 4 plus 1 plus 1 is 62. You have just now solved for the variable by doing the opposite operation and getting it by itself. But I want to go ahead and check my work. The original problem said x minus 14 equals 48. So now that I have x right here, x is 62. So instead of x, I'm going to substitute it with a 62. 62 minus 14, if you do the math, which I'll do it right here on the side, just so you can see. All right, 2, 3, 4, that's 8. 5 minus 1 is 4. And it works. Okay, so I just checked my answer. Let's try a few more. Okay, so in this case, I have 8g equals 24. Now, don't forget, you are always the variable, but in this case, you got to ask yourself, who is in your room? Well, there's an 8 and a g, but there's no operation between them. If you don't see an operation between a number and a variable, you must always put the multiplication sign. What this says is 8 times g equals 24. All right, so let's get the variable by itself. Ask yourself, who's in your room? Well, times 8 is in your room. How do you get rid of times 8? By doing the opposite operation. The opposite of multiplication is division. So 8 divided by 8 is 1. Okay, so I have 1g. And remember, guys, as I've explained in the classroom, if you have 1g, if I get rid of the 1, how many g's do you have? You still have just 1g. All right, let's put our equal sign. I'm going to refer again and again to the balance beam. In order to keep it equal, what you do to one side, you must do to the other. So I'm going to divide by 8, just like I did here. 24 divided by 8 is 3. You just solved it, but I'm going to check it. The original problem said 8 times g equals 24. All right, so I'm going to bring down the 8, the times, but instead of g, you just told me it's 3. So I'm going to put it 3. Well, let's see if this is true. I'm going to separate my rooms. On this side of the room, I have 8 times 3, which is 24. And in this room, I have 24. Are they equivalent? Yes, they are. All right, let's try a few more. Okay, so in this problem, we have x divided by 14 equals 7. Well, we got to solve for x. So again, I'm going to separate my rooms. Okay, you will always be the variable. Now ask yourself, who's in your room? Divided by 14 is in your room. What's the opposite of division? Multiplication. So here I'm dividing by 14. I got to do the opposite, which is to multiply by 14. Once you do the opposite operation, it cancels out. So what you do to one side, you must do to the other. All right, this one I'm going to solve by showing my work. All right, so 7 times 4 is 28. 7 times 1 is 7, plus 2 is 98. So, according to my answer, x is equal to 98. But before I stay there satisfied, I'm going to rewrite the problem. X divided by 14 equals 7. But instead of the x, I'm going to go ahead and get rid of the x, because now I know what x is. Okay, x is equal to 98. So I'm going to put 98 divided by 14 equals 7. Well, I'm going to show my work, make sure that this makes sense. Okay, 14 can go into 9, 0. 14 can go into 98, 7 times, so it's 7. So if I separate my room, 98 divided by 14 is 7, and on this side, I also have 7. And the equation is true. 7 is equal to 7. Alright guys, I hope I didn't confuse you. Now let's go ahead and try a few more. This time we're going to use integers. Alright, here we have x minus 4 equals negative 12. Alright, where the equal sign is, I'm going to separate my rooms. You're always the variable, so I'm going to be x. Now look, who's in your room? Minus 4. What's the opposite of minus 4? Well, the opposite of minus 4 is plus 4. Again, think about money. You owe $4 and you have $4. You're going to pay off your debt, so you're left with 0. X is by itself now. Again, go back to the balance beam. What you do to one side in order to keep it equal, you must do it to the other. So being that these are integers, guys, I like to write my integers side by side. Okay, I added 4 to this side, so I must add 4 to this side. All right, so look at your numbers. You have negative 12 plus positive 4. Because I'm adding integers, I can use my scoreboard. Okay, we're referring back to what we did a few months ago. All right, your scoreboard says you have negative versus positive. All right, well, the 12 is negative, so it's going to go on the negative side. The 4 is positive, so it's going to go on the positive side. Now, let's look at the scoreboard. Which team had the most points? Well, 12 scored the most. That means negative team won. All right, so I'm going to put my negative there because you know your teacher be tripping if you don't put that. All right, so now the next question is, by how many points did they beat the other team? Well, let's check it out. 12 minus 4 is 8. So the negative team won by 8 points. But what I'm going to do is I'm going to check my work using the original problem. X minus 4 equals negative 12. All right, instead of x, I'm going to put negative 8. Negative 8 minus 4, I'm writing everything down, equals negative 12. All right, so what I'm going to find out is I need to find out if this room is equivalent to this room. Let's see. Negative 8 minus 4. Okay, we're subtracting integers. So in order to fix that, I'm going to add a line, change the sign. Now that I'm adding, I can check my scoreboard. Negative team versus positive team. This 8 is negative, so it belongs in the negative. This 4 is negative, it belongs on the negative. All right, so let's find out. The positive team scored 0 points. The total score is 12 versus 0. Which team scored the most points? The negative. By how many points did they beat them? By 12 points. That means that in this room I have negative 12, and in this room I have negative 12. So it is correct. They're both equivalent. Let's try a few more. Alright, so again we're dealing with negatives. I'm going to separate my room. You're always the variable. Now look in your room. Who's in your room? Plus 8. What's the opposite of plus 8? The opposite of plus 8 is minus 8. Again, if you have $8 and you owe $8, you're going to pay them. So you have $0 left. So I have 0. I'm just by myself. K is the only thing on the left side of the room. But remember, going back to the balance beam, what you do to one side, you must do to the other. So negative 10 minus 8. Well, that looks kind of weird. I have a negative and a positive number. Well, I don't know how to subtract, but I do know how to add. So I'm going to add a line, change the sign. So now that says negative 10 plus negative 8. Now that I'm adding, I know I can use my scoreboard. Okay, I can use my scoreboard anytime I'm dealing with, anytime I'm adding integers. Negative versus positive. Negative 10 goes in the negative numbers. And the 8 is also negative. Alright, so I'm going to get my final score. The negative team scored 10 points and 8 points. So altogether, before the end of the game, they scored 18 points. The positive teams, they scored 0. Alright, so now let's look at the final score. Let's look at this. 18 versus 0. Which team won? The negative team scored more points. So I'm going to put that negative. By how many points did they beat them? By 18 points. So in this case, K is equal to negative 18. But again, before I move on, I'm going to make sure I can prove my answer. So I'm going to rewrite the original problem. K plus 8 equals negative 10. I'm going to separate my rooms. Alright, and in this case we said K is equal to negative 18. So instead of K, I'm going to put negative 18 plus 8 equals negative 10. Let's see if this is true. Let's check. Okay, on this side, I know I have negative 10. I wonder what I have on this side. I have negative 18 plus 8. So I'm going to use the scoreboard, negative versus positive, because I'm adding. The 18 is negative, and the 8 is positive. Now, let's look at the scoreboard. Which team scored the most points? The negative team. So I'm going to put a negative sign right now. The next question is, by how many points did they beat them? Well, 18 minus 8 is 10. All right, so there you have it. The left side of the room is equivalent to negative 10, and the right side of the room is equivalent to negative 10. They're both equal, so the statements are true. All right, one last one, guys. This time I'm going to multiply using integers. Okay, so we're almost done here. I'm going to go ahead and separate the rooms. All right, you will always be the variable. Let's look in your room. You're the y. What's happening between the 4 and the y? I don't see anything. So anytime there's no operation between a number and a variable, you're always multiplying. If you don't see it, put it there. All right, so 4 times y equals negative 20. What's the opposite of multiplication? Division. So instead of times 4, I'm going to divide by 4. 4 divided by 4 is 1. That means I have 1 y. That means I see the y one time. What if I get rid of the number 1? How many y's do you see? I only see 1 y. So that's going to stay the same. But remember, what you do to one side, you must do to the other. So I must divide by 4. All right, so what's negative 20 divided by a positive 4? Well, negative and a positive is going to give me a negative. And 20 divided by 4 is 5. So my answer is negative 5. Again, as always, I'm going to check my work to prove it. I'm going to use the original problem, which said 4 times y equals negative 20. All I'm going to do is substitute. 4 times, instead of y, I'm going to put negative 5 equals negative 20. All right, let's see if both of our rooms are equivalent. 4 times negative 5, when I have a positive and a negative, my answer is going to be negative. So negative, and 4 times 5 is 20. And on this side of the room, I have negative 20. So yes, both of my rooms are equivalent. My balance beam is equivalent. Alright guys, I hope this video kind of helped you. I know I went a little fast, but I really hope this helps. If you have any questions, make sure you ask in the classroom. And if you need me to make another video, I'll be more than happy to do so. Thank you.